Who has heard of this word, DevSecOps? Well, that's quite a few of you. Who likes this word, DevSecOps? 2 people. Thank you. I appreciate that. However, the first time I saw this word, I was like, really? Yet another buzzword? Put it next to artificial intelligence and blockchain, and we have a full buzzword bingo card. That's how I felt about this. However, I work for a security company, so let's go into this word, like the white parts, DevOps. Who practices DevOps? Okay, the other folks, still waterfall kind of thingies? Like, who thinks he practiced kind of a little bit of DevOps? Oh, that's the rest, thank you. All right, the thing is, if you look at your development team, or DevOps team, or however we might call it, if you nowadays create a piece of software, and to a certain extent you are responsible for putting it into production, and if something goes wrong, they come back to you, then you pretty much do DevOps. Because it used to be the thing like, hey, it works on my machine, you throw it over the wall, now it's your problem, and you continue with the rest. That was pre-DevOps. Now it's like, we glue it together, we tear down that wall between developers and operations, we can cut down an amount of people because that's good for the company, and now the team is responsible for the whole shebang. That is what we try to do with DevOps, and there's a lot of tooling involved, of course. However, if we look at DevOps, one thing is, we think development is all about features. Look at your Kanban board or Scrum board or whatever agile thing you nowadays use. It's probably something like, as a product manager, I want if you click on this, it does that, right? These are the tasks you might do. But nowadays, like if you compare now the development towards 10 years ago, pre-cloud era, nowadays we think about scalability and maintainability and making sure that my code looks kind of pretty-ish. However, we don't think about security yet, because that's a security team, right? Works on my machine, safe on my machine, now you fetch. But we should take care of that. That is what my talk is about today. This is me. I'm Brian. I work for Snyk. Snyk is a development company that creates security tooling. Let's keep it to that. Yeah, I do some stuff in the community. Primarily, I'm a Java developer. They made me a Java champion, God knows why. They even said I'm the top 21 developer shaping tag in 21 by Business Insider. Still don't know how that was measured, but they did. However, we are here not to talk about me, but we need to solve a problem. We want to solve a problem with that DevSecOps, right? So what is that problem? Let's dissect that problem. First of all, let me take you to my journey, say about 10-ish, 15 years ago. I worked for a government body, a government agency here in the Netherlands. At that point, we deployed our software 3 times a year, which is amazing because at that point you have enough time to make all the crap in the world, then you make a release, then you test it until everything is done, or well, basically you throw it over the wall and they test it until everything works and they put it into production. So basically enough time to do pen testing and that kind of stuff. However, before I joined Snyk, I worked for one of the biggest e-commerce retailers here in the Netherlands, and my team deployed our stuff 3 times a day. That's a whole different ballgame. Because now we need to think about being secure or being feature complete in a whole different way. However, the thing is that if we look at our life cycle, security is not a first-class citizen in the minds of a developer. I mean, I want to build my stuff, my KPI is to make it work, and that product manager is breathing down my neck. And in the end, if it works, ship it. So what we had before with dev and ops, we still have with security. Security is a siloed expertise in many companies that is at the end of the pipeline, and they say no to you. And I hate that, because I can handle that once or twice, but if they keep saying no, I worked 3 weeks on my new feature, that's how our Scrum team works, and at the end of that, it's like, Brian, looks great, but no. That gives friction, because they think I'm a cowboy, and I just want to make sure that everything is feature complete and shipped as easy as possible and as fast as possible. However, we need to think along each other's lines and each other's KPIs, because in the end, we don't want our customer data out in the open. or worse. So you might think like, sure, this is all a great storyline. Probably your marketing company made that up for you. How bad actually is that? Well, let me take you back into a story from 2017. Yep, that is ancient history, I know. But who heard of a company called Equifax? A few. Who heard of that company, that same company, Equifax, before 2017? That's great marketing. I mean, at least now a few of you know that company's name. The thing was, they built their application on top of a somewhat outdated version of Apache Struts. Apache Struts is a framework within the Java ecosystem. Nobody wants to use it anymore, but that's a whole different thing. Anyway, at that point in time, let's say their business logic, the code that they wrote, was perfect. I just assumed that. However, they were using this framework to do the heavy lifting for them, which is cool. However, if you use an outdated framework and it turns out that there is a security vulnerability in it, and you're not paying attention to what is already in production, but just focusing on the new features because, you know, throw it over the wall, not your problem anymore, then you might be into trouble. The thing is, this was, I think the problem was found in March of that year, March 2017. And fixed in March, but in May, they were actually breached. So already 3 months in. It turns out it took about 75 days until they found out, and over 140 million customers got compromised. Currently, I think the damage is about $2.1 billion. How much do we put into security? Well, basically at that point we didn't, because we looked at, or they looked at, new features, and not so much the problem what was already in production. Let me get into this hack right away. I have an application here, and this application runs on beautiful Heroku, just to prove that it's actually on the cloud. Hopefully it runs still. Network is on. Cool. The thing is, it's in the base layer, the framework, so I don't need to go in this application. This has the same Apache Struts library. But what I can do, like a real hacker, normally I put my hoodie on and my hood on, because that's how we should look like in movies. But this is the actual problem. What I'm going to do, I'm going to do a curl request with this header. And this header is, well, just a key value pair. It's a content type, as you can see over here. Who recognizes this content type? Anyone? I see one hand. You recognize the content type? Not sure. Well, it's an invalid content type. The whole thing is, because it's an invalid content type, with this version of Apache Struts, you go down an exceptional flow. In that exceptional flow, for some reason, don't ask me why, you were allowed to utilize OGNL, the Object Graph Navigational Language, which is an expression language within Apache Struts. What I can do with that expression language is I can I can basically call certain methods on certain objects that are in memory, or even worse, I can create new objects. Any Java programmers here? So you know that if I call a new process builder, I can spin up a new process, right? And I feed this process basically the bash, and I say to this bash, give me any arbitrary command. And if what I do, I reroute the output stream to an input stream so I can actually see what's going on. This means if I substitute that word command to something else, I can do an arbitrary code execution. Let's do this. So, environment variables, yeah, I like that today. So let me explain what I do. I take that header I showed you, and I make a substitution. I make a substitution. The word command goes out, the word env goes in, basically saying I want the environment variables. That's a basic Linux command. Everybody knows that, hopefully. Goes to localhost. No, we don't run on localhost, so let's get Heroku. Let's remove this one. Let's try if we can actually do it. Okay. Yeah, just curl request with a specific header. Look what we got here. You see, these are, at least partially, the environment variables of my Heroku pod. That means that whatever I do now, I can execute. So the environment variables are not that interesting, but if I can get the environment variables, depending on what kind of user you're running on, I might be able to create a file with some content, well, basically a script. Come back tomorrow, execute that script. Good luck in your postmortem finding out what the heck happened. And that is the issue. I can do an arbitrary code execution. And that is because I'm using an outdated version of this framework. Well, what do we see here? I see something Java home/app/.jdk. Well, pretty cool. Well, even though we don't see the whole output, doesn't matter. It runs. And the whole, because we don't see the whole output because the output stream, input stream, buffer sizes, that kind of thing. But on the server side, it did run. So that's pretty cool. But that is also how Equifax got breached. They could run things. So if you can snoop around for over 75 days, well, pretty sure you can get some interesting stuff out. So, okay. Say you write an application, and the application, the binary that goes into production is pretty much this yellow ball. How much of this yellow ball is the code you and your team actually created? What do you think? 30%. Oeh, 30%? So 30%? Well, that's pretty large. More or less, normally it's about this. That's 10 to 20%. That is because we might use, well, we definitely use frameworks and libraries. And libraries, bring in libraries several layers deep. And if you're a Java developer, you probably heard of that awful thing called Spring Boot. You do one starter to rule them all. And basically, it's just an empty jar file with a POM file that downloads the internet twice. And what do you actually have in there? You have practically no clue. That big, or that ball in the middle, we take good pride of that code. Who does code reviews? Yes, the rest of you does pair programming. Good. What I just want to say, like, we take good pride of that, as in our code needs to be good, maintainable, scalable, and we look at that and we have code reviews. Nobody can commit to the master branch or main branch before somebody else looked at it. But how do we review everything else that comes in? Because that's the biggest part of our application. In many companies, unfortunately, we don't, or not actively. Just look at your manifest file in whatever language you program and see how many libraries you actually pull in that you might not even use anymore. I worked for one of the major banks in the past, and we had a ton of them. I will not name them, but you can look at my LinkedIn profile. You probably find out which bank I mean. Anyway, let's give you an example. This is a small serverless example made in JavaScript to fetch a file from an S3 bucket. It was 19 lines of serverless code, pretty neat, pretty awesome, and I was like, done, cool. We had 2 dependencies. But yeah, 2 direct dependencies, new dependencies come in because several layers deep. How many dependencies do you think we downloaded from the internet? It's NPM. I heard so many, it was just 19. Not that bad. We can make fun of Node all day, and especially as a Java developer, I like that. But this wasn't that bad. However, my team is not only responsible for the 19 lines of code, because we do DevOps. How many lines of code in total am I responsible for? Just make up a number. What do you think? Trust me, it's not 20 or 21. Pretty much 119,155. And then we can say, yeah, but not every code path is reachable, right? Are you sure? Are you sure there's no way to reach that? Well, some cases you are, but some cases you don't. Because maybe it's possible to run something through something. Because a security hack is not a thing that I have one problem, I have a direct hit, and that's it. Most of the times it's connecting the dots all together, and at the end we have a chain of events, and at the end we have an event that blows up your system. But let's make fun of Java, my ecosystem. Spring, serverless example. 222 lines of awful Java code because I wrote it, and it was a lot of duplication. It was demo code. Not making up any excuses anymore. It was awful. But it had 5 direct dependencies. And 5 direct dependencies verse in many, many more, because it has something Spring Framework, something AWS, so 54 dependencies in total. Again, same number. How many lines of code did my team have to maintain instead of the 222 awful lines of code. What do you think? Make up a number. Again. 1 million. 500,000. You're actually quite right. 460,000, so a little bit shy of 500,000. And remember that in the Java ecosystem, it's such a way that if a class is available on the class path, it can technically be loaded in memory. We just have seen that if I can do an attack with an expression language, I might be able to lift that into memory and actually use it again and create a fine chain of attacks. Marvelous. Anyway, we're not only responsible for the code we wrote. The rest is even though our responsibility, but we don't always take good care of that. Open source usage has exploded over the last couple of years, well, decades so. But attackers are also looking at that because, well, everybody's using it. Why not reverse engineer it and look if there's a problem with it? And if there is a library that is used by many, many people, I have a potential large pool of victims, specifically if y'all don't update your libraries. That's good for me. However, some boring statistics. New packages created per ecosystem per year. Well, we can say that NPM is the clear winner. We can say something about quality, but I won't. However, we know that at current, well, I think the last measurement I found on the internet was about April 2020. They were over a million packages, 1.3 million or something like that. Says something. However, every year we find new vulnerabilities. And in this case, Maven Central, if we take that as the benchmark for Java, unfortunately is the clear winner. But if we look at these dependencies, most of the things, and if we take Maven Central, so the Java ecosystem, and the Node ecosystem as the two largest ones that we serve in Snyk, we see that it's not the direct dependencies that you pull in. Most of it, it's the indirect dependencies that you have no clue that you're actually using them. Because it's just a package, right? I saw this on Stack Overflow, and now it works. Ship it. But underneath, like 5, 6, 7 layers deep, there might be a package that is vulnerable, and that might be lifted in some edge case. And the problem is not that we need to find these edge cases. The problem is that if we don't fix it and we leave that there over time, somebody else will for you. So we asked in our state of open source security, we asked open source maintainers how confident they are in their own code. And well, 63% says kinda. So we blindly trust kinda. However, we need to do code reviews before we can commit to the main branch. Pretty weird. This is the million-dollar question. Who should be responsible for security? Well, a lot of people say, this is a security team because we are builders. But in the end, if you think about it, as a developer, and most of you are developers, right? Developers, hands please. Well, say 99.8%. We've got one manager there. It's good, no worries. Anyway, the thing is, as a developer, we want to have autonomy. So we want to have autonomy to solve a certain problem. We want to do that with our own knowledge, our own code. We want to bring in the libraries that we want to make it fast, scalable, maintainable. But we should also think about securing that point. And most of the times we don't. So it is a shared responsibility between the development team, the security team, and the operations teams because DevSecOps. Yes, it is a buzzword, but it is a thing. Well, let's go to this one. How do you find out about vulnerabilities? 27% says I probably won't because meh. But say, we have a piece of software, we throw it into production. At that point, there is no vulnerability whatsoever. How long does it take before an undiscovered vulnerability gets disclosed? What is the median? What do you think? A year. 5 years. Well, we're actually in between, 2.5 years. So that means, look at your own stack. Is there an application that nobody dares to touch anymore in your landscape or something? Because nobody owns it and it works and people are responding like people need it, but nobody actually owns it anymore. You probably want to look at that one, specifically if it's outward facing, because chances are, and yes, I've worked with these things as well in banks and insurance companies and government, chances are that statistically there might be an issue. But I promise you some hacking, so let's do that. So yeah, we saw this one. We come back to the Java application later, but this is my pretty Node.js application. You see, I'm a very decent Node.js developer, and I can make a to-do list like by, oh, let's do something else because manage extensions. No, don't put one password in. It's not a good thing. All right, I can do something like buy flowers, and then I have it over here. Interesting, I can make a to-do list, super cool. But you see at the bottom there's an about link, right? And I can enlarge it for you. Oh, let's a little bit about. That serves me a static, very modest about page, don't you think? And well, even though it might not be the best looking about page, hey, it scales, so it works on mobile. My UX friends would be proud of me. Anyway, this page it's a Node.js application, very small Node.js application, and this page is served to us by the ST library. And I assume that ST stands for static. Well, there is a problem in this ST library. It has a vulnerability. So what I can do, I can curl this, and I'm way too lazy to type this in, so thank God for copy pasting. So if I do this and I curl it, you will see I will have the HTML. Cool. The problem in this ST library is that it has a path traversal exploit. So I need a bit of your help. If I know there's a path traversal exploit, what is the first thing that you do? // Thank you. So instead of this, let's do // It doesn't matter how many // I do because I try to traverse back to the root, and if I'm in the root and I do // again, I end up in the root anyway. So I can do this a gazillion times, doesn't matter. But if I do this, I get rerouted back to my home page because this is the link to that about page that is rendered. Well, you got me. That is because the ST library actually was created with some sort of a security mindset. Hey, we block that //. But that's exactly the problem. They specifically block //. So, any smart people here in the room that can think of something else? HTML encoding. URL encoding in this case. What is the encoding for a dot? Who says that? Okay, watch that fella. %2e. That is correct. But I'm always curious, like, are you actually a developer or a part-time hacker, breacher, trying this at other people's applications as well? So %2e. You trust that? It's actually a nice question for the next people that comes into your team if you need to do an interview. Like, what is the URL encoding for a //? And they say %2e, like, okay, you're in the security team. Or you're my security champion, or whatever is the buzzword nowadays. So I can do // and I can do this a gazillion times again. And ta-da, I'm in the root of my own library, or on my own system. And then you think, yeah, okay, cool, huh, you can read, boo-hoo, big problem. Well, depending on what kind of level of access you have, you can do all sorts of stuff now. You can read. And reading is not so much a very high severe vulnerability, but I can gather information, and I can use that for my next attack. Maybe I have a properties file over there that has a token or a URL to a database, and I can gather these pieces of information to get my next attack. And of course, you shouldn't be running this as root. But many people nowadays run things in Docker containers, and what is the default user for a Docker container? You guessed it, root. So that is the whole issue. And say we're not going into a public folder. Let's just break out of this. So again, %2e, and I see this is a JavaScript application. So I can go to the package.json to see what's actually in there and look around and see that you have an MS library. And I know by default this is the 071 is vulnerable. Marked is vulnerable. jQuery, whew, that's an old one. That's pretty vulnerable. And you get me. I can gain more information of that. Actually, it's an interpreted language. So we can go into actually the app code. And guess what? Somebody forgot to put the token out. Of course, we did this on purpose, duh. But you get me. I can look into this, and I can gather information for my next attack. So even though I can only read, I cannot alter things, it gives me more information. And nowadays, we know it's all about the information. So I told you something about the MS library. Let me ask you a first question. Who likes regular expressions? Okay, keep your hands up. Who likes reading other people's regular expressions? Who likes debugging other people's regular expressions? You're hired. No, but the problem with regular expressions is that things can go wrong. Say we have this regular expression. You see it over here. And you have, this is the string you want to match it to. How many possibilities does it have? Well, a lot, because this is simply a recursion of the letter A. The point is, it will instantly go there because the first solution wins, right? The problem is if we do this, then it doesn't match right away, and then it goes into traversal mode, in backtracking mode, and it tries all the different possibilities of this regular expression, which at this point is about, I think it's about 100-ish. Let's say it's 100. But that means if I can operate both the string and the regular expression and just add another a few a's, that will exponentially grow. So on how many threads does a node application work? That can only be one. So I'm just occupying that thread with the backtracking of my regular expression. Because there are so many possibilities because of the recursion. Well, let's use that. So I'm using a tool called HTTPI, or HTTPI, whatever. And I can insert in this form on my local host, call mom in 20 minutes. Well, if I do that, it gets back. And what we see over here, call mom in 20M. So it does something with that number and that literal string minutes. Fair? Okay. Now, I'm doing pretty much the same, but I'm plotting 60,000 fives and tries to match that to minutes and see what happens. It takes a tiny bit more, but it comes back. So that means it actually runs. And it says, buy milk in infinity days. So this is pretty much how my normal to-do list looks like. But in other words, I'm always on time. The point is, it matches, because minutes is a literal string it can read. So I work for a company that is based, well, my main office is based in London, and I'm Dutch. So the thing I said to my folks is like, sorry folks, I misspell a lot of things. Don't mind me. So I do that here as well. You see? Minutes with a Z. And if I do it now, it hangs. Going back over here, it occupies that thread. And once all the possibilities are scanned and it basically knows that this regular expression doesn't match anything, it comes back and gives me my computation power back, and the rest of my requests will come in. Think about this. Say you're working for the competitor of Amazon on Black Friday. And we do this to Amazon because they were run on a single node application. Imagine. Nobody can reach Amazon anymore because I just add a few zeros to that 60,000. And everybody comes to me. Because a denial of service is a thing, depending on what your use case is. All right. Java application. I showed you already. Let's sign up for this. Yeah, Brian, yes, give me my email address. Password 123456 because I work at a security company. Nobody will guess that, of course not. So what I can do here, I can create to-dos. Again, we didn't have any inspiration, and I could do something fun like eat pie with a pi sign, put it somewhere in 9070, and give it a high priority because I'm hungry by now. The point is, the pi sign is translated into the ASCII representation. And it uses native to ASCII, which is a function in the JDK. Okay, hold that thought. What we can do as well is we can create to-dos, or we can upload files, and I can upload zip files. It unzips the file and gives the file into my folder. But what if my zip file looks like this? Hold that thought. Oh yeah, we have something with java home/app/.jdk. We need that as well. So let's look at slip. This is my zip file. It contains one file, just a simple file of good.txt, and a second file called // all the way to the root /app/.jdk. I just found out that is where the JDK lives on Heroku. /bin/native to ASCII. I'm using a library to do the unzipping, but this library is outdated. And what this library doesn't do is look at the canonical path, or where this .. /ends. No, it just takes the path, takes the upload folder, concatenates the two, and says, like, put the file there. So what happens is it might overwrite it. So let's try this. Upload file. Choose this file, and let's go into zipslip.zip. I open it, and let's upload it. So good.txt is there in my public folder. This means unzipping took place. But if I create an to-do, I say, hi, GOTO, and put it somewhere in whatever, doesn't matter. Give it a loop, doesn't matter, because now everything ends up in muhahaha, gotcha. Because I overwrote the native to ASCII file that is part of this Heroku pod. Because I'm using a library that is outdated. Because I didn't pay attention to it, and I was like, yeah, it works fine, all my unit tests are green, ship it. Or it's already in production for ages. And just uploading from 1.12 to 1.13 would have stopped this. One more hack, and then I need to slow down because I only have 10 minutes left. Yeah, we all log4j problem, same thing. It was a library, we need to update. And you need to be sure that you can. And I can explain log4j, but I won't because of time. Who uses Docker? Okay, do you take care of do you look at your base image that you're using? Because what is the first line that you do in your Docker file? Exactly. And then you pick something from Docker Hub that is there, you download it, and you put your stuff up on top of that. Well, this is 2019 already. I did a research on the most commonly free Docker containers that were available. I downloaded them and scanned for problems in their operating system. This was the result. The node image had over 500 vulnerabilities. But all these vulnerabilities could be tracked back to the operating system because the latest image was based on a full-blown Debian, at that point Debian Jesse. All these 500 vulnerabilities, because it brings in a ton of libraries or a ton of binaries that have vulnerabilities. First of all, do we need a full-blown operating system for a tiny micro or nano service? Probably not. But also updating these and looking at what you actually need might be a good practice to make sure that these don't bite you in the ass. And I will give you one example of that. I have an application over here, and I will enlarge it. And you see this is the same application as before, but now it runs on localhost. It runs actually on my localhost in a container. And it runs on an outdated Tomcat container. And this is what I'm going to do. That Tomcat container has an issue. In this Tomcat container, it was possible to upload a JSP file to the server via a specially crafted request. The JSP could be requested, and any code that it contained would be executed on the server. So I don't need to touch your application, I just touch your Docker container. Exploit database, because this is already 2017, it's already out. So what does it do? It is a Python script that does two things. The first try, it just tries to insert a JSP file with a println with all A's to see if it actually works. And the second step is to create a form. That form contains a text box and a button, and every time I press that button, we just execute it using the runtime. Basically creating myself a web shell. Well, just for giggles, this doesn't exist yet. So, runs here, Docker container, and this is the exploit I loaded into my screen. So let's check if it works. It will try to upload, it's vulnerable. So that means that the proof of concept.jsp with all the A's do work. The JSP will get loaded and will get executed. So the next one, the web shell, doesn't yet exist. But if I do the command that actually is there for me already, uploading web shell, let's look over here. And now I have a web shell. And guess what? Who am I? Thank you. That means I have full power, full control over your pod. Because you're running an outdated version of this Docker container. And we could have prevented that if we scanned it. And if I scanned it, and of course I'm using my own tools to scan it, duh. But it says I'm using Tomcat 8.5.21, and if I would update to something like 8.5.69, it would already get rid of a ton of vulnerabilities, including this one that I just showed you. All right, fast forwarding to the end of this presentation, hopefully. Yes. Yeah, we did the hack. What is the solution? Well, the solution is three-way: culture, process, and tooling. My company sells tooling, but it's not about tooling. First and most important part is culture. We work with different people: developers, operations folks, security, and management, and I'm probably a lot more, and we all have different mindsets. As a developer, I want to make sure that I build things, feature complete, preferably with new, cool libraries or something like that. But I focus on features, mainly. Operations folks the core operations folks want to make sure that, hey, can I easily deploy it? If it goes down, is it automatically coming up again? These kind of things. Is it scalable? Security, let's face it, have one core KPI: not getting breached. Well, if I just cowboy around and just push it to production 4 times a day, that kind of collides. Think about it. If you look at your manager, and your manager just pushing you to get new features out, what happens? You probably create a ton of technical debt, and at a certain point in time, you cannot innovate anymore. So we ask them to, like, come on, give us some slack that we can get rid of that technical debt. In the same way, as a developer, we need to think about security to help the security folks out, because in the end, we're one team. Then it's process. The best way to adopt new practices is not to create more process, because that happens if you just got breached and everybody is looking at you. You probably tick all the boxes, and after 2 weeks, it's again, because management cares a lot about money, ship it 3 times a day to production. But look at how you work now and how you can adapt that a tiny little bit with some automation and some tooling that fit your current process. Don't buy a tool and say you just have to satisfy that. All tests need to be green. That doesn't work, because the first thing I do as a developer, making sure that I can circumvent that. Hey, I need to make sure that my KPIs work. So tooling is important, but you need to get the tooling that help you the most looking at your current process. Well, of course we can help you with that, but most of the time we're looking at your code, and that is only the tip of the iceberg. Underneath, we have the open source libraries, we have containers, and I showed you one example, and then we've got your infrastructure as code, like Kubernetes, because you can make a lot of problems and issues in there by misconfiguring your pod with too many privileges that is outward-facing and shouldn't be. All these tools are available and can help you, but it's not about just the tooling, it's how you put these into your lifecycle. Don't just do it in your CI/CD pipeline. Why not scan it on your local system? I just showed you my CLI for a Docker container. We can do that for your open source and your static code as well. So before you enter your Git repository, if your Git repository is there connected to a scanner, so it gets scanned like on the go every day. Your CI pipeline, perfectly fine to have it there as well, but not only. Because if you are in production, you still need to watch it. Why not take a step at that point and monitor it? Because at that point, your dependency tree is static, your Docker base image is static, and why not scan it on a daily basis to see if any new vulnerabilities come in? Because we saw that, for instance, with Log4j last December. And yes, that screwed up my vacation too. Anyway, a lot of people say shift left. And they mean shift left in this stage that we need to go into your local machine and start with software or with security from there. And that is true, but it's not enough, because we need to do it at every single stage. Because if you only do it on your local machine, you still have it at one point in time. And again, software development is not waterfall anymore. So we need to continuously scan. We need to continuously test, like we do with unit tests. And hopefully you all have a good unit test suite. And I believe you have. I see people, yes, good. But incorporated in the same way, security scanning and testing with best practices, and then you might be in a better place and already catch more than you catch before. And that's already a win. You don't have to catch everything. If you do it better than you did before, it's already a win. So, this was my story. Oh, nice animated things. If you want to know more on our blog, we have stuff available for Java, for Python, for NPM, all sorts of languages to help you out, to give you some pointers how you can work at these. And these are not specifically tied to any products. So we just want to help you out in that case. If you have any questions, feel free to ask them now, or I will be walking around, and you can ask them later. Ping me on Twitter or old-fashioned email. Thank you so much.